right, folks. Welcome back again. If you came for Solar for Techies, hosted by A&R Solar, you're in the right place. It's just after 12:05 p.m. Pacific time, March 26, 2020, and we're broadcasting from the homes of A&R Solar staff in Seattle, Washington, and Portland, Oregon. We're very grateful for your attendance in these crazy times and hope you've cozied up to your screens with a bit of lunch. I'm Michael O'Brien. I'm one of the directors at A&R Solar, and I serve as our moderator today, and our presenter is TJ Merrill, who's waiting in the wings. So by way of introduction, A&R Solar is one of the oldest turnkey solar installers in the Northwest, now working in our 13th year of business. We focus on high quality solar installations and battery installations for homes, businesses, and utilities. And over the last year and a half, we've become the largest West Coast installer of Tesla Powerwall batteries outside of California. I know coronavirus is on the minds of everyone, so I'll state that as of 10 days ago, A&R Solar has changed our business practices to strictly adhere to health official guidelines. Sales, design, office staff are working from home and engaging with customers at a distance, while our field staff is abiding by the governor's specific orders in each of our 2 states, Washington and Oregon. Please contact us via our website if you have any questions about how we're working. All right, let's get started. So as for housekeeping, your microphones are going to be muted for the duration. So tell your dogs and kids to go crazy, no sweat there. If you have a question, click the question mark on the right and get it in there, and I'll prompt TJ with the questions throughout the presentation and during the Q&A period at the end, which we'll have some time saved for. You can also raise your hand. There's a little button there, but if you're raising to ask a question, you'll need to hit that question mark bubble to tell me what that question is. All right, you should see TJ's screen. I'm going to unmute him in a minute, but it's time to embarrass him a little bit. Thomas J. Merrill, or TJ Merrill, as he's known around here, is a 4-year solar and battery storage veteran and the Washington residential sales manager for A&R Solar. He's a former entrepreneur, business leader, consummate tinkerer, father of 2, UW graduate, and at Microsoft shared the stage with Bill Gates on a number of occasions. He is nationally certified for solar technical sales, sits on the advisory board for several major solar manufacturers, and he is here to present some great content and stimulate some great questions. So take it away. And as I hit the mute button, I'll also mention too, we have some upcoming webinars this coming Tuesday, a deep dive into modern lithium ion battery storage, which he'll also lead. And then we'll have a Solar 101 and intro on Thursday the 2nd. TJ, go ahead and unmute your microphone and take it away. There you go, TJ. Sorry for the delay.
Thank you very much. Thank you for that introduction, Michael. Thank you very much. Everybody, thank you for taking the time out of your lunch to join us for a little chat about current and future solar happenings on the technology front. We're kind of making the assumption that you do have a background in solar. I might touch very quickly on a few key things just to make sure people have some core understandings, but we're just going to kind of dive in. I'd love it to be interactive. So as you have questions, feel free to put them in there, and Michael will kind of fire them out at us. As Michael said, I have a technology and a business background. Originally from Montana. My dad actually did megawatt generators for commercial and industrial. So I've been around energy and technology for most of my life. My father-in-law and mother-in-law built a cabin up near Granite Falls, and I helped them design solar. So I decided I would just dive into it so I could work with whatever contractor we worked with, and I kind of fell in love with it and battery storage, and I kind of decided to make a hop over from high tech, which I'd been in most of my career. So I dived in pretty hard and just love it. I love talking about solar. So fire away with your questions. We are going to focus mainly on residential. As Michael said, we do commercial, industrial, as well as utility scale solar. But for residential customers, it's really using usually an existing structure, your home, your garage, a pole barn, some structure. We also do ground mounts if you have property. So we'll kind of take all of those in. We're not going to be able to cover everything I'd like to cover because of limited time, but we'll answer as many questions as we can, and then we can always move it into a one-on-one conversation. But the first question I like to always answer, and a question that always comes up, is does solar make sense in the Northwest? With net metering, absolutely, and we'll cover really quickly on net metering. I'm showing an example of a monitoring of one of our clients in Seattle. It's this home right here. His goal, his dream has always been to be, mostly self-powered. So he wanted to offset 100% of his annual consumption. So he uses 14,710 kilowatt hours a day. That's about $1,400 worth of energy, and he was able to offset 100% of that. You can see here he's slightly more, but he just got an electric car recently, so he's right in there. And then he liked it so much, he talked his neighbor, his buddy next door, into going solar as well. So it definitely makes sense because this is where the magic happens right here. So our winters are not great for solar production, but in the middle of the year, we are out producing Arizona, Florida, even Hawaii, because our days are long and cool in late spring, summer, and early fall. And all of that extra energy we get to put back on the grid and get a 1-for-1 credit, which is what net metering is all about. So that's really the key that does it, and we were able to, in the last legislative session, extend that enough that it should be able to cover us for many, many years. Once you're in, you're golden. So solar, years ago when it was first installed, in the 70s with Jimmy Carter, it was about $100 a watt. And if you see the cost has gone down, it's in the 50 cents to $1 a watt, depending on what technology you're using. And then you can see, due to that low cost, we have almost an exponential growth in the amount of solar being deployed. Down here, I'm showing modules, different sizes of modules that are available out there, and they usually range between 300 and 410 watts of rated power. I always like to try to put that in dollars and cents. So each one of these modules can offset about $30 or $40 worth of energy per year. So maybe you only have 10 or you only need 10 or 20. Maybe you need 30, 40, 50. Depends on the size of your home, how your home's heated. So it's very flexible. So with global solar deployment, we're looking at over 600 gigawatts of solar in 2019, and we expect that to also grow in 2020. And you can see North America is not the leader. It really has been in Asia and China and Europe, but we're trying to catch up with them. So we're deploying, megawatts worth of solar here in the Northwest just at A&R Solar. Any questions, Michael?
And yeah, you're doing great.
All right, great. So that net metering that I was talking about, so just as for those of you that maybe didn't get to a solar basics class, just very, very quickly, the way solar works, sunlight hits the panels. It doesn't need to be a bright day. It can be a cloudy day even, but that light hits your panels. It's converted from direct current into alternating current. and it flows throughout your home. You use that energy, any extra goes out onto the grid. If you need more energy than it's producing, power comes right back in just like it does any other day. So you get that ebb and flow of power back and forth. The major components of a solar system are the solar modules, and when they're grouped together, they're called an array. Your inverter technology, so you might have a microinverter under each panel or for every couple of panels, or you may just have an optimizer under each panel. We call it module level electronics that allows you to give you shade mitigation and other functionality, and then have a string inverter on the wall, usually next to your meter, and then we interconnect it into your panel. Optional battery storage, so you do not have to install batteries with solar for a grid tied system. And that's what we specialize in, is grid tied systems. If you have a remote cabin, it's really a fairly different system. What we're doing is grid tied, and then when we add in our battery systems, we give you the ability to be either on the grid or off the grid as the grid has problems. But if you have a grid tied solar system, it works just like you're used to today. You're just generating extra to offset your usage, and it goes out. A key thing to note is without the appropriate equipment and batteries, if the grid goes down, your solar, by law, by National Electric Code, has to shut down as well, because we don't want to backfeed power onto the grid and electrocute a lineman trying to work on a down power line, for instance. So,
TJ?
Yep.
Got a time appropriate question here.
Sure.
One participant asks, why do I get discouraged from going off grid or installing an off grid system?
That's a great question. The main reason is net metering. Without net metering, let me actually just jump ahead here to, do I have a good, I'll cover that one. How about this? I'll cover it in just a little, actually no, this slide is a good example. So we discourage you for going off grid because when if you're off the grid, all this extra energy, and this is hundreds and hundreds of dollars worth of energy, you won't have enough batteries to be able to, you would need megawatt hours of storage to have that much power stored to be able to use it here. So instead, your solar system would have to shut down or curtail itself, we say, down to whatever your consumption is. And then in the winter here, now you're going to have to run, a generator or some other form of generation to get it. Or you're going to have to size your solar system so large that you can handle your winter usage here. So I have designed off-grid systems. They are much more complex and much more costly. We may start doing some off-grid as an exception if somebody has a situation where they're building a new home, they bought a large acreage, and the utility, when they go to get utilities, the utilities are saying, well, we need to bring power in 3 miles, and that's going to cost you $150,000. Then it makes sense to look at an off-grid system if you can. I think in the coming years it'll get better, but today it really doesn't make financial sense. Now, if there's an outage, we will automatically take you off grid if we have the appropriate system in place, so that you are off the grid, you're not worried about what's happening on the grid, and you still have key loads powered. Does that make sense?
Thanks, TJ.
All right. So I also like to cover, before we dive into a lot more details, really, what are we here? Why do homeowners go solar? Financially, there's a 26% federal tax credit. Also, energy savings. We usually see an average system paying for itself at least 2 times over the course of its lifetime. And we'll talk about warranties, but we expect a solar system we install today to last 25, 30, 40, 50 years. There are no moving parts, very little maintenance, and we'll talk about that. Thirdly, environmental. We still do have utilities that are majority fossil fuel. So we do have clients that say, I want to use as little of the utilities power as possible because they have coal plants and frack gas peaker plants. So I just don't want to do it. And as a hedge against rising utility rates, utility rates go up between 4 and 8% a year. So as those rates go up, your rate for your power, anything that's powered by solar, your home is flat. You've paid for it, you've invested in it. You could often get a 3-4% loan to finance it, so you don't have to have it out of pocket. And then additionally, when paired with a battery system, backup power, about 20% of our clients do add batteries to their system, either right at the same time as solar or future. And then the final two are preparing for time of use rates and then increasing the home value. And we will next Tuesday. Yep.
Got a quick question for you from the audience here. What assumptions do you make when you're calculating this stuff in terms of energy rate increases from utilities?
So we use in Washington, we look at the history from the energy from the government data for the average increase of utilities. So what happens there? In the past, when we looked at it, it's around 4.5%, 5.5%. So we're pretty conservative. I think we use 4.5% as utility rate increases when we're calculating utility savings over the years. But we do have clients that have come to us and say, I think it's going to go up a lot more than that. So we can modify it so you can see what your utility savings look like. Yeah, EIA. Do you remember what that stands for? It's a government agency. I look at it all the time and I can't remember what it's.
Energy Industries Association, hosted by US DOE.
Yeah, US DOE, yep. So the three major components, and there are more components, but really the key things to think about when you're looking at at a solar system. First, what we do is we look at how much energy is your home using. So historically, can we look back? If it's a new construction, we have some tools to try to estimate how much energy we use so we know what your total energy as far as electricity goes. We can offset electricity, we can't offset fracked gas. So here in the Northwest, we see a lot more heat pumps. So we can offset all of your heating and cooling loads. We can offset obviously all your lighting, refrigeration, EV charging. So when we design a solar system, we're looking at that total annual usage. Like I was showing for our client that I showed that graph on, he wanted to offset everything. We did have data for most of the year, so we estimated it almost spot on, designed a system that met his needs. So the three major components: solar modules, panels, the inverter technology, string inverters, optimized string inverters or microinverters are the most common, and then what, if any, battery system. Now, we always design for a battery system, even if somebody says, I don't think I'm interested. We still like to do the design work so that if they come back to us and say, I changed my mind, I would like to add a battery system, we know we can easily add it and that it's going to fit their needs. So solar modules, there are hundreds and hundreds of solar modules. They usually fall into three tiers. We only use kind of tier 1 modules that we feel are a good balance of quality, performance with good warranties. These are our 4 most popular modules. So they come in different sizes and different wattage classes, each with some interesting differentiators. But overall, that's something a solar design consultant will work with you to help understand, are you looking for a budget module Are you looking for a value module? Are you looking for a performance value? Or are you looking for premium performance? So we'll work with you and can show you lots of different options for them. They are all very good. All of the modules that we carry have a 25-year power warranty, which means after 25 years, they're saying it will produce at least X amount of power, which is what you want. So I'm not going to go into the specs on each one, but these are our most popular modules. Q cells, they're a German engineered module made in Korea. Both come in all black on the left, and we call this mill or tuxedo, or it has a silver frame and a white back sheet. So aesthetics are pretty important. So to a lot of people, so we always like to have options for all black modules. Panasonic has their module made in, I believe it is Buffalo, New York, and Korea, obviously, for the rest of the world here in the United States out of Buffalo. LG has manufacturing all over the world, but primarily in Korea, and for the US market here in Alabama, if I recall, they have a good sized manufacturing plant. And they also have all black as well as tuxedo modules available.
TJ, good question from an audience member. How have trade restrictions affected component prices like modules?
Good question. They have impacted them some. We did have 30% tariff applied to non-US manufactured. So a lot of these modules are popular because we chose manufacturing sites here in the US. Most of the cells, which is, if you look at a module, each one of these squares is a cell. Almost all of I don't think there's any US cell manufacturing. That's almost all done out of Asia. And those cells come in, so only the cells would have a tariff on it. But it did raise our prices a little bit, but it wasn't a full 30% of the entire cost, of a system. It's really just on one major component, or maybe the inverter might have had a small increase in price. But so we did see it go up a little bit, but it's only, a single percentage point.
Thank you.
What I look for in a module, price performance to match your goals. I'm actually just bought a home and going to do a major remodel, and I'll tell you, I'm all the modules you just saw. I'm thinking about which one. I'm trying to estimate my annual consumption. So I'm doing the same thing you'd be doing. I'm looking for that nice balance of price, performance, warranty. Looking at their annual degradation. Anything that's out in the sun full blast is going to slowly degrade. As I said, these modules will work for 30, 40, 50 years, but you will see slight degradation each year. So I'll look at that degradation. And then if it's visible, my roof is going to be up 2 stories and a low pitch 212. So I don't think anybody will see it. So I prefer all black modules because I just like all black. So things to look for. Questions? There's a lot of other things. You can really go down a rabbit hole looking at each individual technology. They do try to do a lot of marketing around it. We can compare them and be able to show you simply, like, here's the performance of that module conservatively, so you can see what it is annually over 10 years, 15 years, 25 years. So we can help you kind of net that all out into something that makes sense.
TJ, got a couple of questions about inverter choices and inverter selection in the design process. Maybe if you're going to get to that.
Yep, going to cover that. That'll be next. So what do you hold that one? So what else is coming on the solar side of things? All the modules that are really in high volume out there are based on monocrystalline technology. And we always like to describe it. It's like a flat screen TV. They get a little bit better, a little bit cheaper each year adding 5, maybe 10 watts, maybe 15 watts each year. There's other stuff that's in research and some stuff that is just coming available. We do get asked about like bifacial modules, but they are a very premium cost. And if you're putting them flush on a dark roof, it makes no sense whatsoever. We kind of look at them more for utility and commercial. If you have a white roof and you're doing a tilt on them, because a commercial roof like the IKEA one I showed you earlier has a white roof, that maybe it pencils out a little bit better. There is a lot of other materials that are being worked on, but they're in the labs. Perovskite and other technologies, but I think they're still many years out. I'm going to finish my home this year. I'm not waiting. I think it's, better to go solar now rather than waiting 5 or 10 years for something that may or may not ever hit the market. BIPV, building integrated PV, has been talked about for a long time. A lot of grade markers along the road. When I looked into it heavily for an architect friend of mine, I found internally we'd looked at it over the last 10 years, and every time we kind of came back really expensive, lower performance, and they use a lot of toxic chemicals. So we do not support the use of them. Solar tiles also have been, DuPont and many others have tried to come out with solar roof tiles, and they've not been successful. Again, usually lower performance, higher cost. Some of you may have heard Tesla has announced announced version 1 years ago. Not sure what happened to version 2. Last December, they announced version 3. They have asked us if we are interested in carrying them. We're asking them a lot of questions. They are doing some test installations, and they are starting to ramp up production. I can say this, the way I look at it is I just had a client who's really interested in it, but he has a flat roof. It's got to be at least 212. So you gotta you really to consider it. If you do want to consider it, it needs to be you need a new roof. It has to be at least 212 pitch up to 12 pitch. So no flat roofs, no super steep roofs, and you're gonna have to be okay with waiting. If you can't get it installed by the end of this year, then the 26% federal tax credit drops to 22%, so you're losing 4% of that value. Solar modules will continue to be the lion's share of the solar PV market and probably continue to increase far beyond it. But it is a nice aesthetic. It is roughly the cost of solar plus a very high-end tile roof. When I looked, when I bought this house, I thought, hey, what's the harm? I'll put my name in, and Tesla designed a system for me. It was 11 kilowatts, and this is, so up is north, so that's a pretty nice south-facing array, but that's only 5, 6, 7 kilowatts. These east-west, you can see here there's a LiDAR view that shows kind of the sun exposure for that roof. I wouldn't put solar on the north roof. So for me on this roof, I probably would question it because I would need roughly twice the area to get similar performance as I would out of 400-watt solar modules. And I still have a lot of questions about their inverter optimization technology. We haven't gotten really much information. So if you're interested in it, certainly you can sign up at Tesla. I am not sure whether or not we will partner with them. We partner with them on a lot of things. We still have a lot of open questions on design, installation, and a lot of other things. So we're happy to talk to you about it, what we know about it. We do have a few more details. We're still waiting for a lot more. Questions?
Thanks, TJ. Moving on to inverters next.
Yep, inverters next.
Fantastic.
So before I jump into inverters, I'm just going to show a couple examples of, roofs that we did a lot of work with the client or their architect. So this actually is the solar array. So it just blends in perfectly. The architect actually designed it so that it would be exactly fitting because that's what he and the client wanted. So it looks gorgeous. So depending on your roof, we always try to make it look really clean, hiding all the conduit, try to fit and balance it. So I think there's a lot of work that can be done if you are concerned about aesthetics, and we're happy to work with you on it. All right, next up, inverters. So this next tier modules is the next biggest question. Which one to go with? I actually wrote I don't know, half dozen 10-page document for our designers that walks them through all of the details, pros, cons, all sorts of scenarios. So there is no one answer. What is right for one project versus another project really has a lot of dependencies. But the two options that we really like is the vast majority of our residential projects. One is an optimized string inverter from SolarEdge. They call it their HD Wave. It is an optimizer plus a string inverter. So beneath each module is an optimizer. And this converts the DC power to a fixed voltage out. So this inverter can be super efficient. It's 99.3 efficient to go from DC to AC. It's a great inverter with lots of advantages. Microinverters are the other one. They're a little bit bigger than an optimizer, but the inversion from direct current to alternating current happens at each module. So it does both the optimization as well as inversion. And it is the leading microinverter in the US. I'm not going to kind of go into a super deep dive in it because we don't have time, but common advantages to both of them is optimizing the production. So shade mitigation, it's just making sure that it's harvesting the maximum amount of energy from each panel. They both provide module level monitoring, so you can see each module and see how it's performing. Both carry 25-year warranties. We do automatically upgrade. SolarEdge's default to 12-year, we upgrade it. Both meet all the latest National Electric Code requirements. Both can be paired with a Tesla Powerwall for battery backup and self-consumption. And both are smart inverters that help stabilize the grid when it's under duress. So when we installed my father-in-law's solar system, the utility guy actually stopped and said, I love it when solar is installed way out here because it helps us with our voltage problems. This is so far out. Sometimes our voltage is a little laggy and solar helps prop it up. And then finally, both are projected to have their own battery solutions in 2020. Again, both of those systems we often pair with Tesla Powerwalls, which is our top selling battery, which we'll talk about more on Tuesday. Is there any additional questions that maybe I missed, Michael?
No, you nailed it. Good job. We also have a question. Where does SMA and their Sunny Boy inverters fit into the marketplace these days?
Yeah, so I didn't put it in there. We primarily use SMA Sunny Boys for ground mounts. With National Electric Code 2017, NEC 2017, we were required to have module level shutdown, and SMA is just a string inverter. So we don't have that module level electronic on each module to do that. We actually have to use a third party, which kind of adds complexity and cost. So on residential roofs, SolarEdge and Enphase are our preference. For ground mounts, it's not required, so we will often do SMA Sunny Boy or other string inverters on ground mounts. Let me know if there's any other questions. some of the things that are new, there's actually the inverter technology is kind of the most exciting. There is a lot of innovation happening from SolarEdge and Enphase, as well as others. Grid-tied inverters are, over the next year, you will see them. There's always going to be low-cost grid-tied inverters, but for just a little bit more, you will be able to get a hybrid grid-tied inverters, which means it has the ability to form a microgrid. So it makes, instead of relying on a separate battery inverter like Tesla Powerwall, which is a battery and a battery inverter, this solar inverter now becomes both a solar inverter and a battery inverter. So it's inverting power. So here in this example, power from solar would come straight through, and instead of being inverted to alternating current, it would go straight into batteries, or even potentially in the coming years straight into an EV. And then if needed, it is inverted to AC and used to run loads. Or if all of this is full, there's not enough loads, the excess will flow back out onto the grid for a credit. So SolarEdge has an existing storage, but really we needed a much larger version of it. So they are coming out with their Storage HD probably mid to late this year. Enphase is going to be coming out with IQ8s at the end of this year. Again, if somebody wants to go solar today, Tesla Powerwall usually works for most people. So you could go solar today with standard grid-tied inverters. And if you wanted batteries, you're fine. But later this year with the IQ8s, they have the ability to form their own grid. All of those systems, and we'll go into it a lot more detail on Tuesday, but there is, in addition to the battery, there is specific equipment to safely disconnect you from the grid when the grid is down, that we make sure that no power is being backfed to those linemen. So there is some equipment plus the smarts in the inverter. And we will cover that in a lot more detail on Tuesday, or if you decide to ask for an estimate, one of our field designers can go into it in a lot more detail. I wanted to show some monitoring because that is kind of the heartbeat. Most of this equipment really doesn't have screens or anything on it, so everything is done via a web browser or a mobile application. Here on the left is an example of a site, and you can see they're generating a little bit less power than the home is using, so it's importing a little bit from the grid. Over here, later in the day, maybe the sun came out, it's generating much more than the home is using, so it's exporting to the grid. Questions, comments?
No questions on monitoring yet, TJ.
Okay. We are at 12:45, so we are going to have a deep dive into Tesla Powerwall, into SolarEdge's future system and other battery solutions on Tuesday. But I wanted to leave 15 minutes for questions on anything I just covered. Happy to go into any level of detail. If you haven't signed up yet, we'll send this link out, or you can go to our webpage, our website, and it'll have the ability for you to log in right there. If you just come to our website, hit our blog, there's Lunch and Learn webinars. And here's the deep dive into modern lithium-ion battery storage. You can register there for it. So the main things we'll be talking about are Tesla Powerwall and some of the other systems that are coming out that we support today, including LG's battery system that we pair with SolarEdge.
TJ got a couple of good questions here. They're starting to run fast, actually. Maybe you're going to get into this on the battery webinar, but how about flow battery storage? Does any of this work with flow?
So flow battery systems, I don't have any content for that. but I do have a friend that is a chemist and electrical engineer, and she was in that side of things. That's primarily for utility scale. So you're not going to see that anytime soon on in a residential environment for storage. I think the most common thing that you're going to see, and what I recommend to people, is you should have a home battery, and maybe it's just one small battery that gives you some basic backup power. If you need a lot more than that, alternate sources of generation. So I'm showing here, this system supports a generator. So that might be a fuel cell. And you got a tank of hydrogen fuel cell, maybe it's a propane fuel cell. For my architect, he has a Cybertruck on order from Tesla, and it has a 240 volt outlet. So I actually designed a system like this. Some of this equipment we're still waiting on, but he wanted to get on our schedule. And again, I can't guarantee it works, but if Tesla says it's a 240 volt outlet that'll work out in the middle of nowhere, that means we can easily integrate it just with an outlet, a power intake. He plugs it into his Cybertruck. So if solar is enough and battery, he can get by with that, then that's all he needs. But if it's a really long outage, maybe it's the middle of the winter, maybe after a big snowstorm, he can pull up his truck, plug it in, and now he's got access to however big a battery is in his Cybertruck, which I think is pretty cool. We call that vehicle to home, or V2H, and I'll have some content for that on the Tuesday seminar.
Thanks, TJ. Yeah, there's actually quite a few questions about EV chargers and EV integration. Specifically, hey, is A&R keeping an eye on bi-directional EV chargers like the wall box?
Yes, yep. I'm talking to them about Quasar. I've actually hooked them into engineering at some of our other partners. We see some really interesting possibilities for that. So yeah, bidirectional charging of EVs. Some other things that we often do is for EV charging, we will install an outlet for you to plug in any EV service equipment. But we are also looking, SolarEdge is just announced a standalone EV service equipment, which is essentially the charging cable and the charging capability. And then they're also going to have one integrated with their inverter, which is interesting. We're looking at it. We want to kind of think through all of the use cases and, where do we, a lot of times we're not mounting an inverter right where it's needed. So maybe a combination of those two would be interesting. So we're looking at those, likely support one or the other or both. I personally like an outlet because it's a 50 amp outlet. I do know how to weld. I don't currently have a welder, but I like the outlet. I can just roll in. I can plug in, my EV chargers plugged into it for my EV. But if my buddy comes over with his Model 3 and needs to plug in, he can just plug right into my outlet. Or if my other buddy rolls up in his RV, he can plug his RV into the outlet. But yeah, bidirectional charging, I think, will be interesting. Each auto manufacturer has to okay it. So today, the only auto manufacturers that have really okayed it are Nissan and Mitsubishi with their CHAdeMO connectors. That is a bidirectional out of the box. They were sort of mandated after the Fukushima nuclear disaster, after the tsunamis. A lot of those companies, including is it Daiichi, they had hundreds of leafs laying around, and they needed power for the pumps, and they didn't have their generators all got swamped. If they had bidirectional, they could have potentially saved that disaster with all of the energy that was stored in those cars. So Japan's definitely leading the way. Tesla is taking a little bit different. They're not doing a DC bidirectional. They're doing an AC outlet, which isn't really exactly the same thing, but for a utility standpoint, our crews would love to be able to pull onto a job site that doesn't have power and be able to plug power tools and batteries and other things into the trucks. So it has a lot of utility.
All right, TJ, got another question here of a different stripe from Russ. Russ asks, if you add battery storage, does your monitoring system from solar change? For example, if you already had sun power?
So if you have sun power, we would probably end up adding a Tesla Powerwall, and then you would use Tesla's monitoring. And I threw a bunch of extra stuff in here just in case. Do I have a Tesla right here? So you'd probably, your monitoring, you'd still have whatever monitoring you have today, but we would probably, for monitoring the battery, you would use the Tesla mobile app for that. If you have SolarEdge, you'd use SolarEdge's app, Enphase's app. If we have a particular battery that's designed specifically for that system.
Right, thank you. Got about 8 minutes left here, 7 minutes, got a bunch more questions. Hey, what's your calculation for if you do have an EV vehicle or you plan on getting one? How do you account for that in building out a solar system?
That's a great question. We actually have, I just added it to our estimating software for our field designers, but usually we do 3 to 4 miles per kilowatt hour, and then we talk with a client. So let's use 3 miles per kilowatt hour. That's kind of on the low end. Teslas are a little more efficient. They're closer to 4. So if you had a Tesla, let's use 4, and you're going to drive 12. You're going to drive and charge only at home. You're going to do 12,000 miles a year. So divide that by 4, that's 3,000 kilowatt hours. So we'd probably add another 3 kilowatts of solar if you have good access to cover an EV. And then double that if you have 2, triple it if you have 3. So we work with clients on estimating all those additional things if it's not in your historical utility bill. But that's what we did for this client that I showed at first, and that's actually just spot on. I kind of laughed when I saw that because we went back and forth and we really tried to get really close. And I estimated he would need between 12 and 15, but then he added a second EV. So we did oversize it a little bit, but it turns out it was perfect.
Perfect, great. A couple other questions here. Maybe you could talk about, some people are curious about DIY projects versus why hire an A&R Solar to do it. What are the cost differences? What are the things to look out for?
I would say probably reach out to us. I could show you all of the documentation, the processes we go through. We do 500 projects a year. There's really, from designing the system, making sure all of your engineering calculations are right, doing the right mounting, the right racking, the right safe wiring, all the utility paperwork, all the single line drawings they're going to require. Certainly if you're an electrician or an electrical engineer, you're probably going to have a better chance of doing it. But if you're not one of those two, my father-in-law was an electrical engineer, and I was like, I'll go and get certified for both design and installation if you want to do it ourselves. But I am so glad that we didn't. That's a 12-12 pitch. And also we watched the crew as they went through. Like I said, I'm a designer, I'm not an electrician, so I'm not doing all the wiring. The care and the thought that they put into installing it, you'll be amazed. Everything down to, they had test leads so that if there was a problem, they could disconnect and reconnect a different set and be able to do tests. Just the runs of all the conduit, is all very professional. It does cost a little bit more, but I personally think it's worth it. I would never think of doing it myself. I'm a certified systems engineer. Even if I went and got my installation certification, I would still hire somebody come in and I'll just help. Like maybe I'll offset it. We can't do that for clients because of liability and insurance reasons. So if you want to do it yourself, we have a couple of companies we can send you that they can try to walk you through doing it. But when we hear of those, they usually are challenging.
All right, thank you. Tell us a little bit about how you integrate energy efficiency measures before or after a solar install.
That is a great question. We do actually have an entire list that we send with our proposals, and we recommend doing those first and foremost. I actually could pull one open. We had a client that really wanted to offset 100%. We looked at his home, and it's like, we really think you should insulate. This is a 1950s era home. It doesn't have very good insulation. Maybe insulate it first, get it buttoned up a little tighter. We can refer them to consultants that can actually do blower door tests and insulation recommendations and put together a plan for it before doing solar. Otherwise, we could end up oversizing a solar system once those energy efficiency measures were done with. The most extreme case that I like to do, he was an engineer in the Army Corps of Engineers, and he really wanted us to design a large system. We tried to talk him out of it. We installed it, and then he really got into it. He insulated his home, and his energy usage went down 50%. So we were 100% offset. Now we're 150% offset because of those energy efficiency measures. After he did insulation in his windows, and then he's like, all right, so now I got more generation. Now he took out his gas hot water and gas heat, and he put in hot water heat pump for heating, cooling, and heat pump for water, and then got a Tesla. So he's kind of got it all put together. So that one worked out very well. But yeah, we'll often look at a home, and this home definitely is using more energy than we would expect. So we'd recommend doing energy efficiency measures maybe first before doing solar, or we can take that into account. You're using 20,000 kilowatt hours today. We think once you do the energy efficiency, you're going to use half that, and we'll design that system.
All right. So that is just at the end of our hour here. Thank you so much, TJ. You're amazing. And just a reminder to everyone, we'll be happy to send out these slides afterwards. This is a recorded conversation. Heads up next March 31st, Tuesday, 12 o'clock. We got that deep dive into modern lithium-ion battery storage that TJ will lead. And by the way, for all of you people stuck at home with kids or maybe high schoolers, and you're looking for a great opportunity to get them educated about something new like this, Solar 101, an intro to solar energy is going to be a great set of topics. Thursday, April 2nd. That probably couldn't come soon enough for some of you at lunchtime, so maybe you cozy up with your lunch. Again, this was A&R Solar's presentation of Solar for Techies, presented by TJ Merrill and Michael O'Brien. Be safe out there, keep those hands clean, stay socially distant, and write us at A&R Solar if you have any questions. Thanks again.
Cheers.